Welcome to Chapter 5, Access Control in the Enterprise. So what are we going to look at? Our objectives today: design appropriate authentication solutions throughout the IT infrastructure. So first, let's take a look on what we're going to be doing. Our homework for the week. We have a couple different things. We have two assignments we're going to be looking at. The first is our discussion of the multi-factor authentication. I want you to spend some time at that. And how does multi-factor identification help us? And how does it keep us secure? These are some of the things we're going to look at. And then the other thing you're going to write is your assignment, Achieving Zero Trust. So you're going to take a look at that. And how do we make sure that what we're putting together makes sense? Not trusting any users or devices. So we have to make sure we have our policies in place and we have everything that we're looking for. So those are our two assignments for the week. So key concepts: access control lists, the ACLs, access control modules, single factor and multi-factor authentication, wireless IEEE 802.11, and best practices for private and public sector authentication. So what we're going to look at, as we know, access control, if we're just looking at one system, it's easy. But when we're looking at enterprise systems, our entire company, all the data, the files, the storage, the databases, who has access to these? And everyone's going to have different access. So because of this, everything becomes a little more complicated. We have to have systems in place that will help us prevent hackers, systems in place that will help us prevent users from not going where they need to be. And we have all our data and backed up storages and who has access to all this. So this is what we're going to be looking at this week. So what is an access control list or an access control entry? So the access control list allows us to create a list of, within the Windows data structure, allows us to create that system that allows, we put a list in who can see what data. So we have a list on who's approved, who's not approved. We don't have to worry about approving it each time. We put this on our list. This is what we're looking at. This is how we want to control who can see what data, when, and how. We can even control times if we wanted to. Usually we don't bother. And the same with the entries. We put all this in there, and usually there's going to, and we discussed this the other day, there's policies in place. Who has access to see this stuff? Who's going to be able to have access to view it? Who's going to have access to edit? And who's going to have access to create? Because we can have all these different levels within our organization, within our enterprise. So authentication factors of what we're looking at. Let's see, let's go back. Hang on a second. Chapter 5. I want to make sure I'm not missing anything. I skipped over something. I'm sorry. So we have the dysentery access control list. It contains access control entries that allow or deny subjects permissions to interact with everything. Then we have the systems access control list, which contains the access control entries allow systems administrators to get into the system. And again, at these levels, the discretionary, the access control list, the access control entries, everything can have different permissions, from read only to read, write, and create, or even no access. So this is where we can set up who can get to what. So it's really an important concept that we keep that in mind, that this is our controlling, and we want to make sure when we're putting this together that we have the right policies and procedures in place to prevent anyone who doesn't want it to have it. So it's usually a signature of the manager and possibly of the IT to keep everything up and board. So a couple things we want to look at also: discretionary access control is the policy that is defined by the owners group. object owner. So if we have the IT department is in charge of these files, it's everyone in that IT department can have access to that. And we have the rule-based control, which is the policy defined by the functions for the users within the organization, for instance, roles of human resources and finance. So here what we're saying is, if I work in the finance department, I might even have a difference between accounts payable and accounts receivable. So accounts payable can see certain files, accounts receivable can see certain files. So this helps us to keep that differentiating between everyone. Mandatory access is policy defined by the system. Attribute-based access, policies and functions of the subject's characteristics. So a manager might have access to certain areas, but they'll have access to more than a user. So these are some of the different things that we wanted to look at. The other thing is the, let's see, that covers that. So why do we want all these in place? Some authentication factors. So that's what our discussion question is going to be on. So what types of authentication factors are there? There are multiple that we're going to look at. So basically, if you remember from the first week, usually authentication is something you know, something you have, or something you are. So something you know is a subject that you're aware of your knowledge, so a password. Something you have can be a token, and something, a characteristic of you can be your iris or fingerprints. So these are the things that we want to look at when we're putting together. So this allows us to protect our data with some level of security. And we want to make sure that we aren't fighting a couple different things. Let me just come back. So what are we looking at today? There's a couple different attacks that can occur. And so when we're creating passwords, we don't want to use basic words, as we've been talking about. Because if we use if we allow users to use just words, it's something called a dictionary attack. They just have a program that tries every word in the English language or whatever language to hack that password, to hack that thing. Then we have the brute force attack, using software code to run through various password schemes with numbers, symbols in it. This takes a lot longer, but it is effective when someone uses password 01. So they are effective for some of the other types of people who don't follow it directly. We also have an eavesdropping. They listen to our networks. This is, if you're in a high-rise building, well, you have where all your electrical throughout the whole building, an electrical closet. So if you're on the 5th floor, well, your wires have to go through the 4th floor sometimes to get up there. So someone can actually listen to you, put a sniffer on it, and get some information out of your thing. But as we've learned in Chapter 3, social engineering is one of the biggest things for giving up information that we need to look at. So we got to keep that in mind. And again, as we covered there, it's all about training. There are a couple other things that we can talk about that we're going to look at. Man in the middle attack, conversation is sometimes communicated. Phishing, happens more. I know every day when I open my email, I have to have at least 24 different phishing attacks from everything. My Target password is violated. My American Express has these extra charges on it. I'm getting a computer sent to me next week. And these are just things to send out that they send out because there's absolutely no cost to them. They have the server and they just send it out. So we got to be aware of this. Spear phishing is a little more pinpointing, and this happened to Barbara Corcoran a couple last year. Someone attacked her, sent her secretary an email looking like it came from a legit place with all the proper information on it, but it turned out to be stealing about $300,000 from her. I think she got most of it back. But this happens. This is spear phishing. They're not sending it to everyone. They're sending it to specific people. And smishing is through your SMS, because I know I am starting to see that more and more. I get spam on my phone all the time now. So again, these are some of the things that we have to be understand, and we have to train our people to understand it. We have to make sure we have our systems in place to prevent it. So if someone gets hacked, they're not going to have access to the entire system. Let's see. So what's single factor authentication, right? That's what we were just talking about. You log in one time, log in, username and password. Single, nice and simple. This is what most people have, but with everything going on in the world right now, this is becoming probably a little more hackable. So many companies that I'm working with are going to multi-factor. So it means I get an SMS on my phone with a password. They might call me. So two-factor authentication really helps us to prevent someone from us being hacked without that second factor, whether you get an email or something on that order. Now, one of the things that companies for really strong and sensitive data, maybe in the finance world, would be a three-factor. Includes all the same. For example, you're going to have a room badge to get in, a PIN number, and a retinal scan because of the room's restriction. So this is something for super critical. So there are a couple of things that we might want to think about. We usually don't get that far, usually up until this point. And I said two factors becoming the standard now, especially with everyone carrying their phones on them. You don't leave home without your phone. Well, you're going to be able to log in from wherever you are. You get the message. And actually, I set this up for my mother because of someone hacking into her account, her Amazon account, and buying a whole bunch of stuff, but we were able to catch it. So now there's a two-factor authentication. So whenever she wants to go on and buy something, she has to get the text message, and it allows her to be safe. So we're going to look at CBTOS authentication. So what is CBTOS authentication? It's a network security protocol that provides authentication and authorization services on the network. Communication on the unsecure network allows attackers to listen and steal a confidential thing. CBTOS uses cryptology in order for the client to prove the identity of the server. Once the identity is proven, the communication is encrypted, credentials obtained are used to verify the identity. And this. So it prevents plain text passwords from being sent over the network. It centralizes usernames and password protection, making them easy to maintain and manage. It removes the vulnerability associated with storing passwords on the local computer. CBTOS is based on three systems: CBTOS key, trusted key distribution system, CBTOS ticketed granted system, and authentication service. So again, it provides transparency for the user. Does not have to know. Excuse me. Does not have to know the CBTOS system exists. He or she only has to know the credentials. Security. The attacker should not be able to obtain users' credentials, and scalability. This allows it to be managed no matter the size of it. So how does this system work? It involves three basic steps: client authentication, client service authorization, and client service request. So it kind of works like this. The following is how it works. The user enters in the ID and password. The client performs a hash. We'll get more into that when we cover cryptology on the passwords created and the secret key. The client sends the information and the request with the password in it. And let's see. So the client receives the two messages. After decrypting the client session key, the client uses that. So you can kind of see how it kind of falls together. It's a two-way communication. So it allows it to have the information we have it. And when we talk more about cryptology, we'll get more into the hash and understanding. Symmetric key is another thing that we can look at for third-party authentication. And this CBTOS performs the authentication as a trusted third-party authentication service with a shared key or symmetric. When the client wants to obtain authentication credentials for the server that it does not have credentials, the exchange between the authentication server and the client is initiated. And we have the key distribution center, which is again a third party that allows us to have this available to us. Some of the weaknesses of it: a brute force attack can break into it, which we've talked about. Key storage: CBTOS tickets are cached on the user's system. Clocks must be synchronized to complete the authentication. So these are some of the downfalls of it. So let's take a look at network access. The network access, called NAC, network admission control, is the use of policies within the network infrastructure to limit access to resources until the system proves that they have compiled enough information. So, layer 2 techniques. Layer 2 of the open interconnected OSI model, which is for your NIC card, refers to the data link layer. The data link layer allows the communication over the wide area network, which allows you to get the information. We also have the wireless protocols that we're going to look at. And as you know, on the MAC address, every MAC address is unique, but it's layer 2 that we're going to be looking at. So the IEEE standard for 802.11 is the wireless. Now, when we're looking at wireless, and this is when, in previous years, this was where a lot of hackings occurred. Target was hacked this way over the wireless internet, and we're going to talk about that too. The layer 3 is the OSI model, is the network layer. So everything works in conjunction. There's 7 layers in that OSI model. And this helps us to do it. So the wireless LANs, IEEE has established a standard for wireless LANs that we use, which pretty much is used more widely today than ever. The access to get on this, we need to have the Wi-Fi protected that we need. We have to have our MAC address. We have the WEP, which is thing, and authorization. So these are some of the things that we look at. We're also going to look at single sign-on. Refers the scope of it. What is single sign-on? It's a method of access control that allows a user to log on to the system and gain access to resources within the network via initial logon. If the single sign-on was not implemented, the user would need to log in multiple times, multiple passwords for each different application. So single sign-on, if I log into my office in the morning, all my applications will open with the same single on. It's confirmed who I am, so it goes back and checks, and it allows it to open up all my applications, so I don't have to log into each application. Again, the whole purpose of this is it saves the employee time and effort. But we have to make sure that it's secure, because if someone gets your login and password, then they have access to all the applications you have. So there is a fine line between, is single sign-on something we should use or not, and it depends on your company's policies and procedures. So we want to look at that. Some best practices that we want to look at. We want to make sure that we have enterprise organizations, that we have everything: discovery, identity, develop policies and procedures, placing appropriate access controls in place, and continuing monitoring. So a quick review. We learned and understood the significance of information within the enterprise helps the administrator grant proper access to those working within the infrastructure. Limiting access reduces risk of the enterprise and assisting in ensuring that data does not get in the wrong hands. So this is what we were looking at this week. So this helps us to provide a level of security, whether we're using single sign-on, whether we're using Wi-Fi, just helps prevent anything from going wrong. The whole idea is we want to protect all of our data, all of our applications, all the time. Thank you, and we'll talk to you next week.